Welcome back. On today's class, let's identify the parent chain of an alkane. I observed that students face challenges identifying the parent chain. And when you cannot identify the parent chain, how can you name an organic compound? So we are going to start by identifying the parent chain of an alkane. Then we can proceed to other functional groups or homologous series. Let's go. So identifying the parent chain of an alkane. Here on the board, we have a compound. The first thing you do is to look at your compound very well to check the functional group that is there. The functional group will now help you to know the homologous series before any other thing. So looking at this compound, it is filled up with single covalent bond, which simply implies it is an alkane, a saturated hydrocarbon. So because it is an alkane, let's get the longest chain. Okay, so what you will do is to identify all the shapes that when you hold the two ends, it can stretch to a straight line without an obstruction. Without an obstruction. That will help you to get your parent chain. Okay, let's go. So here, we have this straight line from here to here. So I will just draw a straight line. How many carbons are there? 1, 2, 3, 4, 5. So I have 5 carbon atoms. Then I have this line from here to here. From here to here. So let me just draw the shape. How many carbons? 1, 2, 3, 4, 5. This is 5 as well. So what other one can I see? I can see this one from here to this point here. That's like this. So let me take that shape. So how many carbons are there? 1, 2, 3, 4, 5, 6. 6 carbon. What other shape can I see? I can see from here down. From here down. So let me take it. How many carbons? 1, 2, 3, 4, 5. So here I have 5 carbon atoms. Is there any other shape? Is there any other shape I can see that is long as well? Yes. Look, I can take from here to this carbon down. It can still give a straight line if I stretch it. So I have from here down. So how many carbon? 1, 2, 3, 4, 5, 6, 6. Is there any other one? I think that is just it. So on that note, is either I'm working with this or I'm working with this, because two of them will give you the longest chain, making the parent chain of this compound to be hexane. So if I decide to work with this, that is from here to here, this methyl group and this ethyl group becomes an attachment. This becomes a substituent. Okay, so if I should work with this, the methyl group and the ethyl group becomes a substituent. If I decide to work with this second one, this one that goes like this, I decide to work with this, then this methyl group and this ethyl group becomes a substituent. So whichever way you want to go about it, as long as you identified hexane correctly as your parent chain, you must arrive at the same answer. Do you love this? Tell me in the comments. Bye.